All right, so in this video, I want to solve these quadratic trigonometric equations over here. Let's take a look at the first one. I want to solve them between 0 and 2 pi. If I take a look at this first one over here, I have cos 2x, a double angle here, and I have cos x here, a single angle. So generally, when you have a double angle and a single angle, you want to convert them all to one. In this case, I'm going to convert this double angle into a single angle using my double angle formula. Now, there are three different formulas for cos 2x, so you got to convert based on what's in the question. In this question, my other term is a cos x, so I want to convert cos 2x into a cos term as well using my double angle formulas. I'm going to switch that to 2 cos square x minus 1. The rest of the equation stays the same. Now I want to multiply this 5 into this bracket. So that's going to become 10 cos square x minus 5 minus cos x plus 3 equals to 0. And then I want to combine like terms. So negative 5 plus 3 is just positive 2. So I have 10 cos square x minus cos x plus, minus 2 equals 0. Now this is a complex trinomial over here. To make it a bit easier to factor, let's just say let A equal cos x. So now I can rewrite this equation as 10a squared minus a minus 2 equals 0. I want to factor this. I'm going to use my man method. 1 multiplies to negative 20 and adds to negative 1. It's negative 5 and positive 4. So I have 10a squared minus 5a plus 4a minus 2 equals to 0. Common factor here is 5a, 2a minus 1. Here it's 2, 2a minus 1. And now I can common factor out 2a minus 1. I'm left with 5a plus 2. And I know my two solutions here for a are positive 1 over 2 and negative 2 over 5. Now I can replace a back with cos x. So now I have cos x equals to 1 over 2 and cos x equals negative 2 over 5. And I can solve these two equations using my cast rule. The cos is positive in quadrant 1 and quadrant 4. I'll do the cos inverse of half to find my acute angle. You can also use special triangles for this one. It's just pi over 3. So my two solutions, my first solution for x here is just pi over 3 because I'm in the first quadrant. My second solution for x is going to be 2 pi minus pi over 3, which is 5 pi over 3. Let's go to this one over here, where cos x is negative 2 over 5. Cos is negative in the second and third quadrant according to our cast rule. Again, I'm going to find the acute angle by doing the cos inverse of positive 2 over 5. Don't put the negative in your calculator or it might not give you the acute angle. The cos inverse of 2 over 5 is 1.16. I'll round the two decimal places. So my first solution over here is pi minus 1.16. And if I do that in my calculator, I will get 1.98. And my second solution is pi plus 1.16. Which is 4.30 or just 4.3. So in total, we have 4 solutions in this question, and they're all over here. Let's take a look at this second question. Again, I have a double angle and I have a single angle, but my single angle is now a sine equation. So I want to convert cos 2x into a sine equation. I'm going to convert it into 1 minus 2 sine squared x, because that's my double angle formula for a sine equation. Rest of the steps are pretty much the same. You want to distribute this 4 into this bracket. And then you want to combine like terms. So 4 minus 7 is -3. Now, when my equation has a negative squared term, I like to move all the terms to the other side or factor out a negative, whichever one. That's going to turn this positive. So 8 sine square x, this is going to turn negative, and this is going to turn positive. Now I'll go let a equal to sine x in this question. So I have 8a square, 0 equals 8a square minus 10a plus 3. And now I can factor this again. My man method, it's a complex trinomial again. So 8 times 3 is 24. My addition is -10. My two numbers are -6 and -4. So I have 0 equals 8a square minus 6a minus 4a plus 3. 2a is my common factor here, 4a minus 3. -1 is my common factor here, 4a minus 3. 0 equals 2a minus 1 times 4a minus 3. My two solutions are 1 over 2 and 3 over 4. And I'm going to replace my a back with the sine x. So sine x equals to 1 over 2 and sine x equals to 3 over 4. And I'm going to solve these with my cast rule again. So sine is positive in the first two quadrants, and both of these equations are positive sine values. They'll both be in the first two quadrants. Do the sine inverse of 1 over 2. Use your special triangles here as well. You'll get pi over 6 as the acute angle. So my first solution, my first quadrant is just pi over 6. My second solution is pi minus pi over 6, which is 5 pi over 6. Coming over here, if I do the sine inverse of 3 over 4, you cannot use special triangles here. You'll get 0.85 if you round to 2 decimal places. So my first solution here is just 0.85 in my first quadrant, and my second solution is pi minus 0.85. Pi minus 0.85 is just 2.29 radians.